Here is a rectangle and a right-angled triangle. All measurements are in centimetres. The area of the rectangle is greater than the area of the triangle. Find the set of possible values of x. So the first thing we'll need to know for this question is the formula for the area of a rectangle and the area of a triangle. So the area of a rectangle is base multiplied by height, and the area of a triangle is half multiplied by base multiplied by height. So we've been told that the area of the rectangle is greater than the area of the triangle. So what we can start this question off by doing is working out what the area of the rectangle and the area of the triangle is. So if we start off with the rectangle, so the formula is our base multiplied by our height. So the length of our base is 3x minus 2 and the length of our height is x minus 1. So we can substitute these values into this formula. And this means that the area of our rectangle will be 3x minus 2 multiplied by x minus 1. Next we can work out the area of the triangle. So our formula is half multiplied by base multiplied by height, and the length of our base is x, and the length of our height is 2x. So this means the area of the triangle will be a half multiplied by x multiplied by 2x. And we can simplify this down to a half multiplied by 2x squared, which we can again simplify down to just x squared. Now the next thing we need to do is we need to form an inequality for these two areas. So we can write that 3x minus 2 multiplied by x minus 1 is greater than x squared. So we'll first start off by multiplying 3x by x, which will give us 3x squared. 3x multiplied by negative 1 will give us negative 3x. Negative 2 multiplied by x will give us negative 2x. And then negative 2 multiplied by negative 1 will give us positive 2. And this is all greater than x squared. Now we can again simplify down the left-hand side of this inequality, and we can rewrite this as 3x squared minus 5x plus 2 is greater than x squared. And the final thing we'll need to do is make this inequality equal to 0 so that we can solve the inequality. So we can finally minus x squared from both sides. And now what we've been left with is a quadratic which we can solve. Now there's a few different ways which you can solve this quadratic. However, I've decided to factorise it. So in order to factorise it, we want to multiply the coefficient of the x squared term by the constant. And this tells us that we need two numbers which will multiply together to give us 4. And then we'll take this middle number here, the x term, and this tells us that we need two numbers which will add together to make negative 5. And two numbers which will fit this criteria are negative 1 and negative 4. So we can rewrite this inequality as 2x squared minus 4x minus x plus 2 is greater than 0. Now what we can do is we can factorise both the left and right hand side of this line. So if we start off with the left, we have 2x squared minus 4x, so we can take out a 2x, and this will all be multiplied by x minus 2. And the same with the right hand side, we have negative x plus 2. And we can factorise this as negative 1 multiplied by x minus 2 is greater than 0. And now finally we'll place this 2x and minus 1 into its own bracket. And this gives us a fully factorised quadratic. So what we can learn from this inequality is that our two critical values for x will be a half and x is equal to 2. Now what this means is when x is greater than a half and when x is greater than 2, then this inequality is correct. However, if we choose a value between 1/2 and 2, then this will satisfy the inequality x is greater than 1/2, but it won't satisfy the inequality that x is greater than 2. So we can just choose this x is greater than 2 value. So our final answer is x is greater than 2. Now this question is worth 5 marks. We get 1 mark for working out both the area of the rectangle and the triangle. We get a second mark for rearranging this inequality to make it greater than 0. We get a third mark for using a suitable method to solve the quadratic. We'll get a fourth mark for working out the 2 critical values, and our final mark for the correct answer.